So welcome back. I think it was really heated discussion, and I'm wondering how many of you want to be uploaded in the future? Okay, almost half of you. And the rest, what do you want to do with your life? I hope that we will get some answers. At least there's one thing what I can advertise to all of you who will be here tomorrow at 10 o'clock, or those who are watching us online. Tomorrow at 10 o'clock, 10:15, we will have meditation session with Monk John tomorrow, 45 minutes. So if you will be here, it will be a great chance for you to discover yourself and maybe start a new, meaningful life. But until then, I would ask Vasco Pedro again to be on stage. And you will be in this great situation that you could refer back to your discussion and maybe to elaborate on some topics. But what I really enjoyed about Vasco Pedro was that when we had the first conversation via Skype, when we were preparing for this keynote, there was this one question that you raised. And you asked me, do you want to talk in line of what Elon Musk thinks about artificial intelligence, or Mark Zuckerberg? So obviously there's a very wide range of how we can talk about artificial intelligence. So the floor is yours.
Thank you very much. Fantastic. It's great to be here. There we go. So there we go. So I'm Vasco. I'm co-founder and CEO of Unbabel. The goal of Unbabel is to enable everyone in the world to understand and be understood. And we very much believe that in order to do that, we need to really create a symbiosis between human and AI. So only the combination of both will give us really the power to achieve this ability to communicate. So I have a PhD in computer science from Carnegie Mellon, natural language processing. For the last 25 years, I've been working and researching in AI and applications of AI. I worked in the first artificial intelligence for Asimo in Honda, and I was part of the team that then led to what became Watson from IBM. For the last 8 years, I've been doing startups where we're applying AI to different goals. And it's really amazing, right? I mean, we're living in this world that feels like the future is just around the corner, right? I mean, we have pretty much close to getting autonomous vehicles. You know, there's people around the world that are already having surgery through robotic surgeons. We're interacting with virtual assistants every day. You know, they're not as smart as we'd like them to be, but they're getting better and better. And so one of the questions that I get a lot is, are we in danger, right? I mean, is AI going to be the biggest danger for humanity, as Stephen Hawking said, or is it going to be something good? And my point of view on this has been that we have been great throughout our entire history at adopting new tools. So if we look, you know, obviously in war, every single time that we developed a new evolution, a new technology advance, we use it for our purposes. So in war, it's very clear, right? We can see that. We can see that, you know, like, unfortunately, sometimes with really bad results, but, you know, tanks in the First World War. We have, you know, the more of the modern warfare with helicopters, planes, and kind of enhanced. So we're getting to the point where continuously, a smaller number of people each time is responsible for having a bigger impact in the decision of battles, right? And we're looking out at exoskeletons. There's drones coming into play that help also enhance human combatants in carrying loads for large distances. And obviously, you know, technology sometimes has disastrous consequences. And a lot of people try to focus on this, right? This is the Armageddon. This is AI will take over the world. But it's not the only thing, right? Because we also do the same behavior in peace. And so if you look in medicine, so this is the box of the first penicillin, 1928. We look at the current state-of-the-art MRI machines, and it's completely different. We look at manufacture. So this was the Ford assembly line. This is the Tesla assembly line, right? So much more roboticized, less people producing much more sophisticated things, high technology. In agriculture, the same thing. You know, used to take 100 people, and now less than 1% of the population is able to produce food for the other 99%. So technology has a huge impact, not just in bad things, but in good things. And continuously, we take every new tool, we adopt it to ourselves, you know, we evolve with it. Computers, the same. So 1950s mainframe to the supercomputer in your pocket that, you know, if you were lucky to order it at midnight a few weeks ago, you probably already have it, right? This is more powerful than, obviously, it's 1,000 times more powerful than the mainframe that you had in 1950 in your pocket. And so another question that I always get is, well, what about jobs, right? We're evolving so fast, will we lose our jobs? But throughout the human history, what we see continuously is that higher GDP equals more jobs. Every time we take technology and we use it to create more value, we're able to then create more jobs. The same thing happened in the Industrial Revolution. And so, will AI have the same effect? I mean, there's no reason to think that it won't. We don't know exactly how, and it could be, for certain, there's going to be a huge transformation in the kinds of jobs that we have, but with AI coming into play, there's going to be more value created by each individual, which will lead to more jobs. Now, you could say that AI is already taking hold, right? I mean, smartphones are, for the most part, already human extensions. I mean, I have mine in my pocket. Probably all of you have one. 90% of us sleep with our smartphones next to our table, next to our bed. They learn our preferences, our locations. They connect us to our friends through social networks. More and more, they learn about ourselves. The problem, though, is that the interface between us and our phones is very limited. Now, it's not the phone itself that is limited. It's not the interface of the phone. Touchscreens work just fine, right? The problem is that we are able to type about 20 words per minute. No, 20 words, more like 170 words per minute, and we are able to speak at 150 words per minute, right? It's like we're less than 200 in either of the interactions. And that's very limited because our brain actually produces enough data to stream 4 HD movies per second, right? So we're streaming at a level, the ability that we have to think vastly surpasses our ability to interact with technology. And I think that's really the key issue that we're facing right now. Now, we can already read a human brain to a certain degree. This is actually since Carnegie Mellon in the last 15 years at least, we've been able to implant electrodes into people with disabilities to help them control robotic arms, right, and to do simple tasks. And which is fantastic, right, especially for the people with disabilities, of course. But it shows the progress, right? Where are we going? And that the fact that human brain and the interaction with the human brain is really the key for us to be able to have a higher bandwidth interaction with artificial intelligence. We need a brain OS. That's something we're lacking. We need something that it can be at the millisecond level and that can help us read all of our neurons in real time so that we can have this high bandwidth interaction. I mean, right now, we're able to read 200 to 300 neurons. That's kind of state of the art. And to give you a sense, I mean, we have 80 billion neurons, right? So even if you apply Moore's law, so in computer science there's a law called Moore's law that it says that computational power roughly doubles every 18 months, right? So your phone in 18 months from now will be twice as powerful as the one you have right now. But even if you apply that to reading neurons, that means that it's going to take us 1,000 years to get there. It means that within our lifetimes, we won't even be able to read part of a mouse's brain, which is not really cool. And so we're trying to surpass Moore's law. There's a DARPA challenge going on right now to be able to read 1 million neurons in real time by 2020, which would be a significant breakthrough. And what we see also is kind of these two trends of reaction to AI. So you have on one side, and Dagnia was saying that Mark Zuckerberg and Elon Musk represent this kind of two trends. One is Mark Zuckerberg saying, no, AI will be good. It will help us. This will unlock new potential for humankind. And Elon Musk saying, no, it's the biggest danger that we have. The interesting thing is that they're both pursuing, in different ways, better ways to interact with the brain. Both Facebook and Elon Musk, through Neuralink, have projects, companies created to create better methods to interact with our brains and to create this high velocity, high bandwidth interaction. So Elon Musk is Neuralink, so the idea there is you're injecting things into your brain, typically, ideally at some point, nanobots, but they create a mesh-like structure that can read neurons. And so you basically have a wireless connection. While Facebook is pursuing neurophotonics, right? So it's non-invasive. They want to use light, in a way, to read your brain activity and to be able to understand your thoughts, to be able to understand kind of speech before you even utter it, and obviously, eventually, do it so that you can select certain thoughts to publish on Facebook. That's kind of the idea. So this is already happening, right? So this is not science fiction. This is happening right now, right? Now, when you talk about this human-AI symbiosis, this high bandwidth structure that we're building, the goal, like I said, is to have this ultra high bandwidth communication network, right? So this will really enable things that we're not even imagining right now, right? Because once you can interact with your brain directly, then you're not limited to 150 words per minute, right? You're actually able to imagine people that can play piano with their thoughts or can interact with their environment, right? You get home, you can turn on the lights, you can, have the dishwasher started, you can be cooking and having the kitchen react to your thoughts and the things that you want to do. And it will also create the ability for us to communicate between each other, right? So once you can efficiently interface with a machine, then machine with machine is, well, fairly straightforward. And so which means that one day I'll be able to just think this talk to you guys instead of having to speak, which is kind of cool. Now, why am I particularly interested in this, right? So language is really the key to the brain. We've been studying language for a long time. And in fact, you could say that artificial intelligence as a field started because you wanted to solve machine translation. That was kind of the first application. Obviously, people thought at the time that you were going to be solving this in about 10 minutes. 10 years. But obviously, they were wrong. I mean, it's now been 60 years, and we're still kind of closer, but not really as close as we like to think. And the reason why language is a key to the brain is because, in a way, language enables you to understand what's going on in your brain. So, and I'll talk about this a little bit more, but a lot of the processes that we have working in parallel actually then get streamed, they get instantiated through language. We ourselves only become aware of what we're thinking when we put it into language internally. So there's more and more studies that show that whenever you're having complex thought, the only way for you to be aware of that thought is when you put it into an internal language. And so language is a required component for you to be able to think, whatever that language is. And in fact, depending on the language that you use to think, you will be thinking differently. So, English versus Portuguese versus French versus Chinese, they actually have and encourage different structures and different ways of thinking. And so that's why actually learning a second language actually opens up your brain to new connections and new ways of thinking. And so there's been a lot of work done on mapping the brain. And there's a couple of things that have been very surprising. One is that, contrary to what was thought initially, language is not really a left hemisphere kind of thing, right? So we used to think that language is on your left hemisphere of the brain, and then your right hemisphere of the brain is for logical stuff. But actually, that's not how it happens. What we're seeing is there's recently a project that just built this map, language map of the brain. And what they did is they took students and they did functional MRIs, so while students were being read to, and recorded what was the activity that was going on in their brains and which area lighted depending on the words they were hearing, right? And what they saw was that the brain is already categorized in a sort of semantic mapping. So, for example, when students hear the word top, they're going to think of there's an area of numbers that gets activated because of the top numbers. There's area of spatial recognition that gets activated because top can have a meaning of being top of a mountain. So all of the meanings that this word can have get activated in the brain and processed in parallel. And so kind of what's emerging, this theory of cognition where your brain is actually a parallelized machine, meaning that in every given point, you're actually processing thousands of data streams separately in your brain, right? You have stuff going on with, image, stuff that you're seeing, sounds that you're hearing, assumption is your world, your spatial awareness of where you are related to other people, your emotions, maybe things like memories that are coming up. So all of this is being processed in parallel, and then, it gets coalesced and serialized at the moment that you utter it in language, right? And so, in a way, that is kind of the moment where you become conscious. That's your sense of self, is when you put things into language, when you speak internally or external, where you decide where to put your attention, right? So it's a mechanism that forces the brain, this massive parallel machine, to then focus on one simple thing, right? And language is a way of bringing everything together into one coherent thought. And it's only at that point that you really understand and have the feeling of who you are, right? And so, in a way, this feeling that we're one thing is an illusion that is created by language. And so it's very important to study this. And now the other interesting thing is when you think about what AI is and how will this AI merge with humans, there's kind of two areas that you can think about this. One is, everything that's going to happen before language, right? So imagine, you're having a conversation, and imagine Google Maps is plugged into the area of your brain that leads with spatial awareness. So not only you're able to understand kind of where you are, but you have all of the knowledge of where everything in the world is and the distances and how to get to places. Or if you're talking about a certain person, not only have your own memory and you plug in Wikipedia to the area that stores memories about people and that processes people, then you have access to not only your own memories, but information about everybody in the world. And maybe your social networks are plugged into that area too, so that you have information in that moment about what every one of your friends is doing in terms of the people information, right? So your conversations can be vastly enriched, right? But yet you can have all of this happening, before language at each different subdivision, subunit, and yet once you coalesce it into one single thought, you're still going to have your own sense of self, your own conscience. There's no indication that you and your perception of self will be altered, even though you're merged with artificial intelligence, right? The only difference is that you'll have a conversation that is vastly better, right? You have access to information and parallel processing power that is several orders of magnitude what we have right now in our brain. And so another way of thinking about this is, throughout human history, so we have the limbic system and the neocortex, and there are two different regions in our brain. And the limbic system came first, right? It's responsible for our fight or flight responses, for our kind of lizard brain, the very raw emotions. And our neocortex is what enables us to do, high-level thinking, high-level functioning. Now, you can think of AI as being a third part of your brain that is evolving, that is being created right now, that's going to exist outside of your brain. And it's going to interact with each of the parts of your neocortex that are responsible for certain areas and augment them in this tremendous way. So we'll truly be augmented human beings. Now, the other part is everything that happens post-consciousness, right? Post-self, right? And that's kind of the human-machine interface that enables you to do human-to-human communication. So telepathy, interaction with your environment, everything that has to do with outside of yourself will happen post this phase, right? And this combination of these two things is very powerful because you can have AI-augmented humans that even though they're augmented by AI in all different aspects of their brain, they're not even aware of it, right? Because by the time it comes to language, it's all, coalesced and serialized into one coherent thought, but then the thought doesn't even have to get to actual utterance of language, because you can then interact with machines that enable you to interact with other humans, and then you can communicate that telepathically, right? Which not only you can communicate telepathically, but you can communicate instead of 150 words per minute at the equivalent of 4 HD movies streaming every minute, right? So it's the exchange of information, even between humans, and your ability to process that information is going to be so much bigger, that we're going to be able to exchange information at such a rate that all of your ideas and my ideas will be able to flourish at an incredible pace. Of course, this will mean that there's ethical questions, right? It's one of the biggest issues, and I think that because even what is this good or bad, right? We just had this amazing panel about mortality, which is very interesting, but this will kind of bring this into play, right? What is mortality? If more and more of your brain exists outside of your brain, then what does it mean to die? Does it mean that it's your language center that dies, or does it mean that your sense of self? Because a lot of the parts of you will continue to live because they're outside of your brain anyway, right? And I think that, of course, this has to be really dealt by bioethics and neuroethics, and it's a discussion that will take a long time. But one thing is that historically, we have been incredibly good at making use of tools that give us advantages, right? And once this advantage exists, once you see the abilities that people can do with access to this technology, then it will be very hard for all humans not to do it, because it will be a big disadvantage not to do this. And so I think it's inevitable. And then the question will be, what does it mean to be human at that point? We as humans, always have this sense, and a lot of it is pre-programmed, of this sense of like we're unique, you know, that we are able to do things that other people can't in some way, that we're the better at something or worse at other things. But there's some very interesting things. So for example, we're already seeing some deep learning networks that the way that the networks structure themselves is similar to the way that our brain structures itself when it comes to things like special areas to deal with inanimate objects versus animate objects, right? And if you look at the study over mapping of the brain over humans, there's a very big overlap of, you know, there's a very big similarity of different, like the same areas within different people, meaning that we're not as unique as we like to think. We're complex, but we're not as unique as we like to think. And so a question in my mind has been, you know, what will it mean to be human 100 years from now or 200 years from now, right? And I think when it comes to AI and the job of AI at that point, the way I think about it is more like an orchestra, right? An orchestra where our conscience is the maestro of an orchestra that is composed by biological and non-biological subparts, instruments. Each of them has a different function, but it will add to the overall ability to create a symphony. Right? It's just that instead of having a quartet, you're going to have a bigger and bigger symphony, better tools, better instruments, better sound, higher fidelity. And so, I mean, the question I want to leave you with is, what if, you know, if you think about it, we as humans have always been great at doing things that are really bad to other humans. We never needed the help of technology for that, right? I mean, doing very inhuman things has been a very human characteristic. And if AI is going to evolve and be part of us, and if we're going to have access to, you know, better information, higher quantity of information, better processing capabilities, it means that maybe our decisions are going to be better decisions because they're going to be based in better data and more processing power. So maybe AI will actually help humans become more humane because we will be making better decisions. And that's a very nice future to have. Thank you.